Moore machine. Draw a Moore machine that count for how many times the substring 001 occurs in a long word. Draw a Moore machine that count for how many times the substring 001 occur in a long word. So what we need to do in Moore machine, so whenever 001 completed or come, we need to print 1, otherwise we need to print 0. Whenever 001 string will come, we need to print 1, otherwise we need to print 0. That we need to do. So we start with the initial state Q0 and we put 0 here, and we give a loop of 1 here. Now from Q0 to Q1 we will give 0 here also. For Q0 to Q1 we will give 0 here also, and we make a transition of 0. Then again Q1 to Q2 and we make another 0 here. We give 0 because what exactly we need? 001. Whenever 001 come, then it should be 1. So 0 0, and we make another state Q3, and here we give 1 because 0 0 or 1. So whenever we reach 001 string, then it will print 1, otherwise it is 0. That's why we make a loop of 1 here, and this is 1, this is 0, this is 0, and for 1 it will move here, and for 0 we can make a loop of 0 here, or for 1 it will go to Q3 state, and for Q3 if 0, then it will move to Q1, and for Q3 1, then it will move to Q0. So this is the Moore machine, in which whenever it will print 001, it will get 001 string, it will print 1, otherwise it will print 0. Let's check how it will work. Suppose we have a string 1 0 0 1 0 0 0 0 1 1 1 0 0 1 0. So what we will get initially in Moore machine, whatever we have in our initial state, we have to write it here. So we write it here 0, and for next one from Q0 to 1 where we are moving, we are reaching on Q0 only. So what we will get here? 0, and again for 0, this is for 1 0, then this is for 0, then what we will get? We will reach on Q1, what we will get? 0 for that 0. Then again for 0 we will reach Q2, then what we will get? 0. Then for 1 where we will reach on Q3, then what we will get? 1. So we can see clearly whenever we are getting 001 string, we are getting here 1. Now move to the next, again 0. So from Q3 to 0 where we will reach Q1. So for this 0 we will get 0, then again 0 we will reach Q2, then we will get 0, then again 0, we will reach on Q2, then we will get 0. Again 0, we will reach on Q2, then we will get 0. Then for 1, we will reach Q3 and we will get 1. So again, when we are getting 0, 0, 1 string, then we are getting 1. Then for 1, we are reaching on Q0. So for this one, this is 0. Then again 1 on the same Q0. So we are getting 0 here. Then for 0, we are reaching Q1. So we are getting 0 here. And again 0, we are reaching Q2. So we are getting 0 here. Then for 1, we are reaching Q3. So we are getting 1 here. So again for 0, 0, 1 string, we are getting 1. And for 0, then we are reaching Q1. So we are getting 0 here. So here we can clearly see that whenever 0, 0, 1 string will come, it will print 1. So this is the Moore machine. And how many times substring 0, 1 come will in that long word, it will print 1. Otherwise it will print 0. It is clear from that string. Now move to the next. Draw a Moore machine. Draw a Moore machine that print one's complement of binary string. One's complement of binary string. So we start with the initial state Q0 for 0 and Q1 1. For 0 it will print 1, and for 1 it will print 0. For 1 it will print 0, and for 0 it will print 1. 0, 1, 0, 1. For 1 it will print 0, either from this, either from this, or for 0 it will print 1, either from this, either from this. Let's check it with the example. Suppose we have a string 1, 0, 0, 1. So as we know, whatever it is having in the initial state, it will come first. So we will write 0 here. And for next one, what we will get? 0. For 0, what we will get? 1. For again 0, what we will get? 1. And for 1, what we will get? 0. So here we can clearly see this is the one's complement in for binary string. Whenever we are getting 1, we are getting 0. Whenever we are getting 0, we are getting 1. Now move to the next. Draw a Moore machine that count number of doublet in a word. Count number of doublet in a word. We started. I started with the Q0 initial state. Make a 0. Q0 to Q1 0 1 0. Then Q2 1 2 0. Whenever we are getting doublet 2 0, then we are getting 1. In the same way, we make another state Q3 and we give a 0 for 1 1 and for 2 1 1 1 2 1. Whenever 2 1, whenever doublet occur, it will get 1. So now see the rest condition. Q0 to 0 1, Q1 to 0. Whenever 1, it will come here. From Q2 0, it will reach here 0 0. Whenever 2 doublet, it will get 1. For 1, it will come go this Q3. From Q0 one condition is there. Whenever it will give 0, it will go to Q0. So from Q0 0 1, from Q1 0 1, from Q2 0 1, from Q3 0 1. So whenever we are getting doublet either in this way, either in this way, either in this way, we are getting 1, or here from getting 1. So whenever it is giving it doublet, then it will reach here on Q2 state and it will give a 1. So in the similar way as we are counting in those two, whenever it will get doublet, it will give us 1. So this is the Moore machine for that.